far off. Around 42 ppm. Looks great. That's right on where it should be. We're 26496. So you're not too bad. Okay, 1121. ppm. 995, we should be 997, so 2 milli mass units, which is only 1.5 ppm.
So did you figure out?
Yeah, it just, the first mass calibration looked like it just sucked.
Even though, so why did it pass and suck?
Because we do RMS. Root mean square, so we do them all together. And if you do, the RMS can, if some of them are high and some of them are low, it
so
kind of...
the root mean square across all the different peaks? Is that what you're saying?
Yeah, and it just...
So it's an average?
Yeah, and it just averages out, it averaged out the crap.
So there seem to
but
be
they all
that
kind
were
of...
low, and that were high, and then...
Yeah, it was all over the place. Where the hell am I typing?
That's weird.
That's why I tell you, always just do...
Okay, we need to do this from now on.
Just to, just keep an eye on to make sure that...
Because it'll pass. That was off by, it was 100 ppm.
Yeah. Hey, mathematics is an interesting branch of science. I always find with the right math, you can really...
You would think this would be something that the software would pick up on.
Okay, we're 1.9 ppm.
So sub 2 ppm is the goal?
Sub 2 ppm is the goal at now. I make my measurements at sub 2 ppm for 5E5. Okay, so we're going to go back in. Once I know that this calibration is sub ppm at that level, then we're going to go check your 1E6 and see how close you are. Okay. So this is just to prove that the instrument did what it was supposed to do.
But even up to 3E6, it's supposed to get sub 2 ppm, isn't it?
Oh, no, no, nope.
Is that not the case?
No, that is not the case.
So that's like 20 ppm up there?
I don't, the problem is instrument to instrument, that AGC is kind of a questionable number. So we always say 5E5 sub ppm is when the instrument's working properly. Screw that one up. 0.7. Okay, so with this mass calibration, you're in from 0.7 on the bottom, 0.2 for the MRFA, 1.4 and 1.9 for the Ultramarks, which makes sense. So
Why
you have
does that make sense?
because our mass accuracy is inversely related to mass overcharge. So we get our best mass measurements at low. Smaller the M over Z, the better the mass measurement. Okay.
It's not normalized for this.
Okay. So you have a good mass cal. Now let's go up to 1E6, where you've been running, which should take my IT time 2x. Right? We double the number of ions.
And we're not IT limiting.
Right, we're not IT limiting. So don't ever do, without averaging turned on, don't do mass measurements. We always want to have. Now, we are now back to, I might have dumped the calc, I think. Divided by 195. So we're 0.7 ppm. For the caffeine.
So you're set it at 25,000
25,000 res. Yeah, the res won't affect your mass accuracy. So it's a little chilly in here, isn't it?
Wiser wants to keep it cold to save time.
Oh yeah! Oh yeah! Man, you're dead on in the MRFA. Gotta love 1/100,000th of a mass unit off. Yeah. Now let's check your 1522. .2 ppm. Okay. So you saw what I did? We always check our mass accuracy, which is theoretical minus experimental, divided by theoretical times a million. Okay. We always check it at 5E5 population with 10 scans averaged. They all should be below 2 ppm. If it is, then I'm cool with my mass accuracy. Then, since you guys are running at 1E6, I do a pop-up to 1E6 and I make sure I get about the same mass accuracies. They'll be a little bit worse, but make sure